Hello guys, in this lecture I shall be teaching you about externalities. We will be taking care of theory aspects of externalities. Our first topic is called consumption externalities, also known as a popular case known as smokers versus non-smokers. We assume that there are two persons A and B. A likes to smoke and B likes clean air. They both like money, and we further assume that they both have rupees 100 each. With OA as origin for A, smoke and money are economic good. With OB as origin for B, clean air and money are economic good. Therefore, the ICs are convex for both A and B. So now we will have an Edgeworth box showing this sort of scenario. Guys, we all know that in order to have an Edgeworth box, this is how one can have it. This will be the origin of A and this shall be the origin of B. Now guys, you need to be smart. Suppose here we are taking income. See, they both have 100 bucks each. So the total income is gonna be 200. And here I'm taking smoking. So guys, for A who likes to smoke, both income and smoking is an economic good, right guys? Whereas for B, this is income, but this shall be a clean air. Now, if smoking increases, clean air falls. If clean air increases, smoking reduces. Now, since they both have 100 rupees each, guys, we can do this. Suppose this is point C and this is suppose point F. You can call it any name. So C and F. Now, may I say at C, if you look from the point of view of A shall be having at this point C 100 rupees as money and 0 smoking. But if you look at point F from the point of view of A, he'll be having 100 bucks and full smoking. Guys, again, be cautious, try and understand the concept. This C shows from the A's point of view that he has 100 bucks and 0 clean air, 0 smoking I should say, because here it will be 0 smoking. But if you look at point F, again from the point of view of A, guys, A will have 100 bucks and full smoking rights. This one is showing that full smoking is there. Now if you look this F point from the point of view of B, so B will be having 100 bucks. B will be having what? 100 bucks and 0 clean air because smoking will be there by A. If you look at this point from the point of view of B, he'll be having 100 bucks and full clean air. So you've got to be very, very smart here. मैं repeat कर देता हूँ आपके लिए. They both have 100 rupees, total becomes 200, right? This is smoking. So if smoking increases, clean air falls. If clean air increases, smoking falls. Because it has to be consumed by both. Now, this is point C. If A starts from point C, he'll be having 100 bucks and 0 smoking, right? But if you look at point F, again from the point of view of A will be having 100 bucks and with full smoking right. B के point of view से उल्टा हो जाएगा. If you look at point F from the point of view of B, he'll be having 100 bucks and 0 clean air. And this point C from the point of view of B will be having 100 bucks and full clean air. तो पहले इसको क्लियर कर लीजिए. अब मैं आपको सिखाता हूँ कैसे इस एक्सटर्नैलिटी से हम इसको दूर कर सकते हैं या कैसे हम इसको बेटर कर सकते हैं. So for that I have got some example for you. So case A, suppose in this case B has the property right to clean air. In this case both A and B shall be at point C. So this is the point C. If B has the right to clean air, that means A can't smoke. That means A can't smoke. Okay, so this shall be starting with point C. So before we proceed further, let's show you something. This is an imaginary, you can say transaction line, budget line, whatever you want to call it. And suppose these were the ACs. This IC is for A and this IC is for B. They are convex because if you look at from the point of view of A, income and smoking are economic goods, so convex. From B's point of view, clean air and income is also, economic goods, so again convex. So now suppose we assume that B has right to clean air. So if B has a right to clean air, that means A must be at this C point, because he'll be having 100 bucks, no doubt about it. But don't you think, guys, he'll be having no smoke because he doesn't have the right to do so. Now the property rights rest with B. B has the right of clean air. So let me give you something first. So for B, OBF units of money and OBT units of clean air. So this is OBF and this you can say OBT. So OBT clean air B will be getting, and OBF money he'll be getting. What about A? OAC units of money and 0 units of smoke. So this is OAC units of money and 0 units of smoke. Now guys, since B has the property right, they can actually do some transactions with each other so that they can both be made better off. So I'll be using one example here in order to clear my point. Now suppose A offers B 20 bucks. In that case, B will be having 120 instead of 100, but A will now be left with 80 bucks because he must have given those 20 bucks to B, right guys? Now by doing so, A is achieving a higher IC, say ICA1. Why? Because now he has 80 bucks and this much of smoking right. So earlier he was having 100 bucks, 0 smoking right. Now he's having 80 bucks with this much of smoking right. What about B? Well guys, B is also made better off because this is B's ICB1. He'll be having 120 bucks and this much clean air. So earlier he was having this much clean air. Now he'll be having this much clean air, but he'll be having 20 bucks more. So by trading with each other, my dear friends, by trading with each other, they have both made themselves better off. So this is consumption externalities of one case where the property rights were resting with B. Now what if the property rights are with A? That is, A has the property right to smoke as much as he could. Don't you think in that scenario we would have started with F? If A has the smoking right, in that scenario, my dear friends, we would have started with point F. Now again, that imaginary exchange line, a budget line, whatever you want to call it. So in that case, this would have been IC of A again, and this would have been IC of B again. Now suppose A has the property right to smoke. Right guys? Now in this case, my dear friends, B can actually go to A, B can approach A and request him to smoke less. For that, he can offer him some money. So for example, B requests A to reduce the amount of smoking because he doesn't like it. Well, A first refuses it. Then B tells him, okay, I'll compensate you, I'll pay you something. So in that case, suppose B pays A 20 bucks. Now don't you think A shall now be having 120 rupees? But then A shall be having this much smoking, OA till here. Earlier he was having smoking from OA till here. What about B? Well, B also is having a higher IC because now he is left with 80 bucks. No doubt about it. But don't you think he'll be having this much clean air as well? Earlier he was having 0 clean air. So during consumption externalities, one thing is apparent, guys, that is without property rights, one cannot have a Pareto optimal point. So if there is a consumption externality, there is bound to be a Pareto failure. If you want to achieve Pareto optimality, then guys, you need to have a point where you have the property rights. So without property rights, one cannot find Pareto optimality in normal consumption externalities. But then we have got one exceptional case under consumption externalities, where even if you don't have the property rights, still you can end up having Pareto point. So that will be our next topic, that is popularly known as quasi-linear preference or coase theorem. So I shall be teaching you. So guys, I will now be teaching you about the exception under consumption externality. Well, this is popularly known as quasi-linear preferences or coase theorem. Now suppose we have got A as having a utility function as x1 plus vx2, where x1 is money and x2 is smoke. Now, if you look at this, utility function, you will quickly notice that it's a case of quasi-linear preferences. Now, you must have done it in your third semester, but if you don't remember it, let me give you an idea. A quasi-linear preference is such that up to a level, your income increases, the demand for that good also increases. But after a certain level, income change does not affect the demand of the good in any way whatsoever. And that is what I have tried to write in point number 2. Increasing income does not change the demand for smoke. So this is the diagram OAS. So this is the smoke, where even if you give him more money, you bribe him. Suppose here A had this smoking right. B comes up to him and says, okay, reduce the smoking, take some money. In terms of quasi-linear preferences, he will not be accepting that. Now, thus reallocation of endowment shall not impact the efficient level of externalities. Remember the normal case where mutual give and take actually gave them a Pareto efficient point. But here, the preferences are such that even if you offer the other guy some money in return of either less smoking or clean air, depending upon who has the right or who goes to whom. Here that doesn't work because the preference is quasi-linear, which says even if you increase income, the consumption of their other good, in case of A smoking, in case of B clean air, that's not gonna change. So now B's utility function is also x1 plus vx2, where x1 is money and x2 is clean air. Increasing income here as well does not change the demand for clean air. So in this case, the contract curve shall be the locus of tangency point like E1, E2, E3. So guys, even if they don't have the property right, in the case of quasi-linear preferences where both A and B are having quasi-linear preferences, that means, bribing them or, giving them more income does not give them more utility. So because of that quasi-linear preferences, their consumption of smoking and of clean air is gonna remain same even if you offer him or them rather more income. So in general, during consumption externality, one cannot have Pareto efficiency unless and until we have got the property rights. But we have got one exception in this form of coase theorem, which says that even if you don't have a property right under consumption externalities, you can still have Pareto optimal point. So guys, this was all about consumption externalities, and now we will be looking at production externalities. So guys, now I will be talking about production externalities. Well, we have to have first some assumptions. So we have got our first assumption. There is a firm S that that produces steel and dumps the waste or pollutant X in the river. Another firm F, a fissure, is located downstream and adversely impacted by firm S pollutant X. So far we have got two firms, steel firm and a fissure. Steel firm produces steel and dumps the pollutants in the river, whereas the other firm fissure, who catches fish, is adversely affected by those pollutants which has been dumped rather by the steel firm. Now we have got third assumption. Cost function of firm S is given by CSSX, where CS shows cost of steel firm, S is the steel cost and X is the pollutant cost. So where S is the amount of steel and X is the amount of pollutant produced. Similarly, we have cost function of firm F, which is given by CFFX, where F is the amount of fish and X is the amount of pollutant. आइए आगे की बात करते हैं इसमें अब हम आपके लिए. Now guys, we have one more assumption which you should all have a look at. So our fifth assumption is that firm F cost of production of fish depends upon the magnitude of pollutant X produced by the steel farm. So it says delta CF upon delta X is greater than 0. So this implies that increase in the production of pollutant X increases the cost of providing fish. So this is shown in the following figure as MCF. So guys, this upward sloping MCF shows that more the pollutants, more shall be the cost of catching fish for the fisher farm. And now we'll talk about the steel farm. Well, it says change in cost of steel with respect to change in X is less than 0. This implies that increasing the amount of pollutant shall decrease the cost of producing steel because the output increases. Now, this shows that if the quantity of pollutant increases, that means production is more. And if the production is more, guys, then we assume that the overall marginal cost, falls for the steel farm. So this is MC of fishery. This is MC of steel farm. MC of fishery, shows that with increase in quantity of pollutants, the cost of catching fish is also increasing. Whereas MC of steel shows that with increase in quantity of pollutants, the cost of producing steel falls, because if the pollutants are more, that means you must be producing more as well. Now, we will now talk about how they are gonna maximize their profits. So steel firm shall maximize profit when the difference between TR, that is price of steel into quantity of steel, and total cost of producing steel is maximum. So in normal way, we write profit function as TR minus TC, and first we maximize the profit function by differentiating it with respect to S. If we do so, this is what we are going to get. So we have price of steel, that is price of steel, minus delta CS into S star X star upon delta S is equal to 0. You can also write it as PS is equal to this. So first, this particular condition of yours tells us the profit maximization of steel firm with respect to S. You can simply say TR minus TC was the profit function, and you have maximized that profit function with respect to S, that is steel. And this is the final outcome which you must be ending up with, which says PS is equal to delta CS S star X star upon delta S. Here stars are showing the profit maximization. Now this implies that the price of steel must equal the marginal cost of producing steel at the profit maximizing output. Now if you differentiate with respect to X, I am afraid you really can't do it really. Why? Because the MC of the pollutant is 0. So this implies that the profit maximizing quantity of pollution is achieved when the MC of pollutant is equal to 0. This is attained at X star level of pollution. The student must remember that the price of pollutant is 0. Because the price of the pollutant is 0, mera bacha, so TR, which is P into Q, shall be 0. And then you are just left with this. 0 is equal to marginal cost. So the steel firm S takes into consideration only the cost of producing steel when determining the profit maximizing position. It is therefore only concerned about its private cost. The steel firm does not take into consideration the external cost which it imposes on the fish farm when determining its profit maximizing position. This results in private efficient level of output for the steel firm, but one that is socially inefficient because it is not considering the total cost. To be precise, it is only considering the cost of steel but not cost of pollutants. Now mera bacha, we shall be maximizing the profit function of firm F, that is fishery. Again we will take TR and TC, and the difference between TR and TC we're gonna maximize. Let's see what we can do. So price of F into F, that is TR for fishery, and cost function is already there. Now differentiating first with respect to F, we are left with equation number 7 is important for us. PF is equal to delta CF F star X star upon delta F, which says that in order to maximize profit, this fishery farm must have this condition which says that the price of fishing is equal to the marginal cost of fishing. Now if you want to differentiate with respect to X, I'm afraid you can't do so because this fishery farm do not produce pollutants, that is X. So you cannot really differentiate your profit function as fishery farm with respect to X because you're not actually producing that. Let's have a look. So this condition implies that the price of fish must equal the marginal cost of providing fish at the profit maximizing level of output. In this case, we cannot differentiate with respect to X because the fish farm is not producing pollutant but is affected by it. So guys, so far we have seen that there are two firms, steel firm and a fishery firm. Steel firm produces two things, steel as well as pollutant. Fishery firms is adversely affected by the pollutants, though it catches fish, and the cost of catching fish by this fishery firm increases with each increasing amount of pollutant which is dumped by the steel firm in the river. So now I shall be telling you about the ways through which you can actually combat the situation of externality and can actually achieve the Pareto optimality. The first is mergers. So as the name suggests, the both firms will merge. So let's see what happens. Suppose the steel and fish firm merged, resulting in a single firm consisting of two divisions, a fish division and a steel division. Now in this case, this we call it SF firm. How will they maximize their profit? Now don't you think, guys, their total revenue will now be price of X S into S plus price of F into F minus the combined cost of function of both. So mere bacha, now if you maximize this profit function with respect to S, the equation 9 is identical, my dear friends, to equation number 4 which we did. That says that price of steel should be equal to marginal cost of steel. Now if you differentiate the whole profit function with respect to F, that is equation number 10, you get PF minus delta C F X upon delta F is equal to 0, or PF is equal to marginal cost of catching fish. This, my dear friends, is identical to equation number 6 or 7, or rather 7. Now here you can actually differentiate with respect to X, which you do, and by doing so you get your 11th equation. So condition 9 is similar to 4 with the exception that equilibrium output of merged firm is not S star X star, it is S double prime and X double prime. And now dear friends, condition 10 is similar to the condition 7 with the exception that equilibrium output for the merged firm is again F star and X star. It is condition 11 that is critical. This condition implies that the sum of MC to the steel division and the marginal cost to the fish division is 0. So my dear friends, equation 12, this is the main thing which will give us the Pareto point. This says marginal cost of steel should be equal to marginal cost of fish. And whatever solution we are going to go for to eradicate, to overcome the problem of production externalities, this condition will be there, which says marginal cost of steel should be equal to the marginal cost of fish. How? Let me give you an idea. This was the diagram and that's the point. E, that's your Pareto point. Why? Because here your MC, my dear, MC of steel farm is equal to the MC of fishing farm. Clear, guys? So this was merger, one way of eradicating the problem of production externalities. Now we've got the second one. It is known as taxes. Now you tell me, the pollutant was dumped by the steel firm, right? So logically the tax should also be imposed on that firm. Let's see. The second mechanism to cure this production externality is tax. For the independent steel firm, the production of pollution had no cost. The firm therefore ignores the external cost that its pollution, or rather its pollutants, imposes on the fish farm. To rectify, we place a tax on this pollutant produced by the steel firm. Let us call that tax rate as T per unit. Now don't you think if there is a tax, the cost will increase, the cost of steel firm will increase by T. Let's see how it affects. Now guys, please have a look. So now to maximize profit, we say total revenue minus total cost, but this time total cost will also include tax. So this profit function looks like equation 13. Now if you differentiate it with respect to S, you get the same earlier equation, and now if you actually differentiate with respect to X, you get T is equal to MC, and my dear friends, that T is equal to MC Actually, this condition 15 is equal to condition 12, where tax should be equal to the marginal cost which the fishing firm has to bear. So this is one again a situation where through taxes you can actually overcome the problem of production externalities. Let me give you some idea again. Through merging, one can get rid of the problem of production externalities. Second, through taxes, and tax should be imposed on the firm which is creating that externality, in this case a steel firm. So again you will be getting the same situation. This tax is equal to marginal cost of steel, and that tax has to be equal to the marginal cost of fishing firm, because the government will obviously see how much cost increase is due to the pollutants and accordingly will impose tax. Now there is third way of eradicating the problem. This is called setting up a market for externalities. Let us have a look. The magnitude of the effects of most externalities can be influenced by action of either of the agent, not just the agent who causes the externality. For example, the victim of pollution could move its operation to less polluted water, or he could have used some technology. The steel firm could also use a different technology which caused less pollution. In such cases, efficiency requires both agents to act to reduce, minimize, or even eliminate the damage caused from the externalities. So there is a missing market for the pollutant. So in this case, guys, we are actually giving them a property right, as we did in the case of consumption externalities. Assume that the fish farm had a legal right to clean water. The fish farm is now in a position to allow pollution provided it is compensated by the steel farm. So suppose let Q be the price of pollutant per unit and X is the magnitude of pollutant that the steel firm produces. Shall represents the amount of money that the steel firm shall pay to the fish farm for the pollutant so caused. Now don't you think if the steel firm has to compensate the fishing firm, the cost function of steel firm will increase, whereas the profit function or the total revenue of the fishing firm will increase because they will be getting the compensation for each unit of pollutants. So first we have again the steel firm. If you see their profit function, their total cost has again increased. Earlier they had their original cost function and now they have extra price which they have to pay in order to compensate the fishing farm. So again you differentiate with respect to S, you get the same equation. You differentiate with respect to X and you get Q. Q was the amount of compensation per unit is equal to MC. Now don't you think the fishing firm will have their total revenue increased by the amount of compensation? So as you can see, guys, the bottom, the new profit maximizing function for the fish farm shall be maximized in order to maximize profit will be total revenue plus the compensation minus the total cost. So the firm who compensate will increase their cost, and the firm who gets that compensation, well, it should increase their total revenue. And now we will maximize this profit or profit function of fishing firm. First with respect to F, again you get the same equation. Now if you differentiate with respect to X, you get this, and replacing Q with each other, you again, guys, ending up with the same condition which says that the marginal cost of steel firm should be equal to the marginal cost of fishing firm. So far we have got three solutions: merging, taxes, and giving property rights. Well, guys, we again have a fourth case. In this case, again, there's a property right, but with a difference. So assigning legal rights to the agent generating the externalities. Padhte? In this case, we assume that the steel firm will have the right to pollute up to a level of X bar. The fish firm is willing to pay Q per unit to the steel firm. For the steel firm, revenue shall be generated from sale of steel and from reducing pollution. Now in this case, that steel firm has a permission or has the limit or has the right to create pollutant to a certain limit. If the fish firm wants the steel firm to have less pollutants than that the limit which they have the right for, then they have to compensate the steel firm. So in this case, fishing firm will be compensating the steel firm in order to reduce the quantity of pollutants less than the quantity they were assigned. Let's see. So for the steel firm, revenue shall now be generated from steel and sale of steel and from reducing pollution. Therefore, the profit maximizing equation for the steel firm shall be total revenue minus total cost. But then this time, total revenue is first price of S into S plus Q, that is the compensation they'll be getting from the fishing firm, which will be equal to X bar minus X. So whatever their limit is, whatever output they reduce from that limit, they'll be getting a compensation regarding that. Cost function remains same. So now again you maximize the profit function, and again equation 24 is the same one which we earlier had in so many occasions. Now if you differentiate with respect to X, you again get Q is equal to marginal cost of steel. Now the profit maximizing of fishing farm, don't you think fish farm is now compensating, so their cost will increase, don't you think so? So or the revenue will reduce. So that is precisely what is happening. PF into F minus QX bar X, because the revenue will fall, cost function remains somewhat same. So you differentiate with respect to F, you get the same equation. You differentiate with respect to X, you get Q is equal to MC of fishing. So replacing Q with each other, you again have marginal cost of steel is equal to marginal cost of fish. So we have four solutions, four ways to get rid of production externalities, guys. One, you can merge. Second, impose taxes. Third, property right. In a particular case, the firm which is creating pollutants, that should compensate the other firm. And in the last case, they were having the right to have the pollutants up to a limit, and if the other firm wants that the pollution should be reduced from that level, they'll be compensating the polluting firm. So guys, for numericals you can watch my other video. So this was all about theory of externalities.